Hi there. One of the things that you're going to want to be able to do with your project data is to split it into separate segments. And it's much better for you to create first an ARFF file and split that than to split a CSV and then to load each one and turn it into an ARFF file. The reason is clear if we think about our ARFF file format. So if you're not familiar with this, you should listen to the video on the ARFF file format first. And just to review, we have the same flow here. At the top of the file, we've got @relation and the name of the file. Then we've got the list of our features with their types and some additional information depending upon the type. Then @data, and then each row is an instance. Now, if you were using a set of these ARFF files together, Weka will expect that the header, that's everything between @relation and @data, is the same for all of those files. And if you split the data as a CSV into segments and then load it into Weka to create the ARFF format, then you can't guarantee that across each of those it will construct the same header, and sometimes that causes problems. So to avoid that, you could take the CSV file, load it into Weka, and create the ARFF file format and then split that. Now you could split it either by creating separate text files, manually copying in the header, and then manually copying in part of the data. But there are also ways of being able to do that inside of Weka, which may or may not be less tedious, but at least they're most likely less error prone. So first, let's think of it in terms of a cross-validation. So when we talked about cross-validation, and it was a 5-fold cross-validation, the data set as a whole was the rectangle that you see on the screen, and it was divided into segments. If it's a 5-fold cross-validation, it would be divided into 5 segments, and on each fold, one of these is going to be your test set, and the rest of the data is going to be your training set. So here's what that looks like in terms of the ARFF file format. So it's the data underneath the @data part of the file that would be divided into 5 segments. And so there will be some data that is in each segment. Now, if you are doing a cross-validation, you need 2 files for each fold, a training set and a testing set. Both of those files will have the same header, but the test set will be one of the segments underneath @data, and then the corresponding test set will have all of the other segments that weren't included in the training set. And so that's what you want to end up with if you want train test pairs per fold of a cross-validation. And I'm going to show you a filter that will do that for you. But we also talked in class that if you're not doing a cross-validation, you might just want to take all of your data and turn it into a train set and a test set. And if you do that, then you simply want to split the rows of your data in half of them going to train, half of them going to test. Now in this particular example, this is a good example of where you wouldn't want to preserve the order that's in the data set, because you can see how we have inadvertently put all of the examples with gender female in one half and all of those with gender male in the other half. And that's almost certainly a bad idea. Unless what you want to do is see how if you train a model on one gender, it generalizes to the other gender. Okay, let's not get into too much data because this is really a toy data set anyways, but it is a good idea to think about. Is it, based on how my data is ordered, do I want to preserve that order? What are the implications? And depending upon what it is that you're testing, it may or may not make sense. Okay, so if what we want to be able to do is create the train test pairs so that we can train for each fold on the training set for that fold and test on the testing set for that fold, so that we can see, for example, the separate tree that would be built on each fold if we used decision trees? That was one of the questions that some students have asked. So you can use a filter that you can get from the front panel, the pre-process panel of the Explorer, called Remove Folds. It's called Remove Folds because you start out with the whole data set, and each time you run it, you remove one of the sets that you need for each fold. So for example, you always need, for cross-validation, on every fold, a training set and a test set. So when you run the Remove Folds filter, you have to, for each fold, run it once to get the training set and once to get the testing set. And I'm going to show you how you can do that splitting with this. But I'm going to also tell you, well, let's say you wanted to split into halves so that you could get a training set and a testing set that cover the whole data set, so that you have half in train and half in test. You can actually use Remove Folds to do that, even though that's kind of a misuse of it. It's not really what it's designed for. It's designed to remove, or to create actually, those data sets that you need for cross-validation. Now there's a supervised version of this filter and an unsupervised version of this filter. And in the evaluation unit, we'll talk about stratified cross-validation versus unstratified. So the supervised version is the stratified version. That means that for each segment of data, we have a random selection of instances that preserves a class value distribution. So if we divide our data set into, let's say, 5 segments, then each of those 5 will have the same distribution of class values, and we will have distributed the instances to meet that constraint in a random fashion. In the unsupervised version, we preserve the ordering from the original set. So each one of our segments is just a segment of data, and it's ordered. So the things that are close in the original file will be within the same fold of the segments that I created. Okay, so I'm going to select one of these Remove Folds filters from the menu. I can get menus because there's the supervised one and the unsupervised one that I get to from the Choose button. So you can see here now I have that. And if I click that text, it brings up the object editor for the Remove Folds filter. Now if you look at it here, you can see some information that we need to fill in. So we've got fold, so which fold am I on? If I'm doing a cross-validation, if it's a 5-fold cross-validation, I'm going to iterate between 1, 2, 3, 4, and 5. But you can see here num folds, so I'm telling it how many folds. And then invert selection tells it, am I doing the training set or the testing set? If I'm doing a 10-fold cross-validation, I'm going to run the filter 20 times because I'm going to create 10 test sets and 10 corresponding training sets. So invert selection I will set to true if I'm creating a training set and false if I'm creating a test set. That's just the convention that the people who programmed Weka decided to have. Now if I'm doing a stratified Remove Folds, then I want to set the pull-down menu to the class value. And so that's how it knows when it runs it that that's what it should keep constant across the different sets. So the distribution of class values, it's going to keep constant if it's doing a stratified Remove Folds, which is the supervised version of the Remove Folds filter. So for each time that I have configured that object editor, I'm going to click this Apply button. Now notice that I have number of instances underneath that, so where it says Choose and then Remove Folds, it says Current Relation, and then it is going to say whatever was after the @ relation, and then it has number of instances. Now when I click Apply, I'm going to create a subset of the whole data set. So I started out with 19,936 instances. Now when I click, then I'm going to have a subset of that, and then I'm going to save that. And then when I want to create the next file, I'm going to click the undo, and that will bring me back to the full set of data. And then I'm going to keep iterating through that to create all of my sets. So each time I tell it what fold am I on, how many folds total, am I creating the training set or the testing set, then I click apply, and then I'm going to save that, and then I want to undo to get to my whole set, and then I'm going to reconfigure that to create the next set. So each time I go down to a subset from the original set. Now once I have created all of my train test pairs, then I can actually run my cross-validation. For each fold, I'm going to load the training set on the Preprocess tab, and then when I get to the Classified tab, instead of cross-validation, I'm going to select Supplied Test Set. I'm going to click the Set button, and that brings up the little widget that you see in the upper right-hand corner. And when I click Open File, then I can navigate to where the test data is, so I can load that. And then I'm going to click the Start button to run the experiment. And what happens is that I have loaded the training set, I have tested on the test set. So instead of doing cross-validation, I just load one and load the other one separately. Now if I wanted, instead of a cross-validation, to just have half of my set that I train on, half of my set that I test on, then I would set the number of folds to 2. Then I would still run the Remove Folds filter twice, once for the training set and once for the testing set. If I just wanted to split the file in half, keeping the order the same, I would do the unsupervised version. But if I wanted to randomize the data so that between train and test I had the same class value distribution, I would do the stratified remove folds, which you get from the supervised version of the Remove Folds filter. Now when I load the training set that I created that way on the front panel, and then I use Supplied Test Set and load the corresponding testing set here, now I'm going to train on half and test on half. So I've used this Remove Folds filter as though I was doing a cross-validation, but if I set it up for a 2-fold cross-validation instead of 10, then each fold will have half of the data as training and half of it as testing. But since it's half and half, I really only have to do that once, and I have one file that's half and one file that's half. And if I swap which one I'm treating as my training set and which one I'm treating as my testing set, I would get the other fold, but I really only have to train on half, test on half if I'm doing this half-half. So remember that I'm not doing cross-validation. If I have used remove folds, I'm using a supplied test set. That's what my test option is going to be. I click on Set to open up the Finder that I see here, and then I'm going to select what I want as my test set. Okay, so that's how you can use the Remove Folds filter to split your data set. And you will do train test pairs frequently. Well, not too frequently. You'll need to do it on your data set for your project for assignment 4, and then later in the semester when you are working on tuning, you'll work with train test pairs again. On one of the midterms, you also need to be able to do train test pairs. So you'll refer back to this video, and if you have questions, go ahead and post those to Piazza.